if the area of the small circle is 25 pi, then what is the area of the green region? To find the area of the green region, first we will have to find the area of the large semicircle and subtract the areas of the orange circle and the two semicircles. In this process, we will need to use the formula for the area of a circle. The formula for the area of a circle with the radius r is A equals pi r squared. Now let's talk about the orange circle. If the area of this circle is 25 pi, then the radius will be equal to 5. And that is because 5 squared equals 25. So now here in the figure I have the radius of 5 units. Now to find the radius of the yellow semicircles, we will start by connecting the center of the orange circle with the center of the yellow semicircle. We will also need to connect the center of the orange circle with the center of the large semicircle. And now what we have here is a right triangle. Let the radius of the yellow semicircle be represented by letter r. So the bottom side of this triangle is r. The hypotenuse of this triangle is the sum of radius r and radius 5. Now the right side is 2r minus 5. And that is because if the radius of the yellow semicircle is r, then the radius of the large semicircle is 2r. So this line segment is the radius of the large semicircle and it is 2r, and to find the right side of this triangle we need to subtract 5. Now in this right triangle, let's apply the Pythagorean theorem. That is, one side squared plus another side squared equals the hypotenuse squared. So we will write r squared plus 2r minus 5 all squared equals r plus 5 squared. So now if we solve this equation, then we will find the radius r. First we will need to remove these parentheses, and for this we will need the formulas for the square of a sum and the square of a difference. Here we have the formulas, and the first one is a plus b to the second power equals a squared plus 2ab plus b squared, and the second one, a minus b squared, is a squared minus 2ab plus b squared. So let's apply them. Then we will have r squared, then 2r to the second power is 4r squared minus 2 times 2r and times 5 is minus 20r, and then 5 squared is 25. Now on the right side, first we will have r squared, then 2 times r times 5 is 10r, and 5 squared is 25. Keep in mind that we could also use the FOIL instead of these formulas. Now, before we continue, we will cross r squared on both sides as well as 25. So now we have 4r squared minus 20r equals 10r. If we subtract 10r from both sides, then we will have 4r squared minus 30r equals 0. In the next step, we will factor out r, and in parentheses we will have 4r minus 30 equals 0. Then we will apply the zero factor property, and we will write that r equals 0 or 4r minus 30 equals 0. Now here, let's ignore the first solution because the radius cannot be equal to 0. Then from here, if we continue with the second equation and we add 30 to both sides, we will have 4r equals 30. Then if we divide both sides by 4, then r will be equal to 7.5. So we just found the radius of the yellow semicircle, and that is 7.5 units. Then we can say that the radius of the large semicircle is twice r, which is 15 units. Now, once we have the radius of each circle, we can put it all together and find the area of the green region. First, let's start with the area of the large semicircle. That will be pi times 15 squared all divided by 2. So again, pi times 15 squared all divided by 2 because we need the area of the semicircle. Now let's subtract the area of the orange circle, which is 25 pi. So here we will write minus 25 pi. And now we need to subtract the areas of these two semicircles. Together they form one full circle and the radius is 7.5. So we will subtract pi multiplied by 7.5 squared. Here we can use a calculator and we will get 125 over 4 pi, which is approximately 98.2 square units. So we found the area of the green region and it is approximately 98.2 square units. I hope you liked this problem. Please subscribe to my channel, leave a comment, and thank you for watching.